So let's say that I have an alternating series that converges. So what I can do then is I can use a partial sum, S sub n, can be used to approximate the total sum S. Okay? So I'm adding up a finite number of terms in my list, and that's estimating for me the total sum. But anytime you do an estimation, you're always worried about how accurate your estimation is. Okay? So, but we need to know, we need to estimate the accuracy of the approximation. I need to know how close am I to the actual sum. So what I'm talking about is error, how far off we are from the total sum. Well, that's just going to be what I call R sub n. The R stands for remainder. It's the difference of S minus S sub n. Okay? It's how far off you are from the total sum. So let me tell you how to estimate your error here for these, okay? So this is called the alternating series estimation theorem. And I will write it for you. So if you have a series, if A sub n is an alternating series with sum S, and you need this alternating series to meet the conditions of the alternating series test, so it's got to have Bn plus 1 is less than B sub n, and the limit of Bn is 0. So if it meets the conditions of the alternating series test, then the error, Rn, which is from my remainder, is bounded by Bn plus 1. So let me give you a second, and I want to explain what this is saying. So let's say I take some partial sum, S sub n. What that means is I add up my first several terms, right, up to an. If this is an alternating series, these signs are going to have to change, okay? But what it's telling you is that the error comes from this next term. There's an upper bound, and it comes from that next term. The absolute, this B sub n plus 1, remember, it's just you're taking the absolute value of the terms in your series. You're making it positive. So the upper bound for my error comes from where I cut off my series. The next term in my series That's gonna give me my upper bound for my error. Okay? So let's take this idea and use this on a problem. Okay? Example. Find the sum of the series -1 to the n over n factorial correct to 3 decimal places. So the first step is that we have to make sure that this series actually converges. I need to use the alternating series test. So let's start with showing part 1 of the alternating series test. We should identify what is our b sub n here. What's b? What's the remember I said 1 over n factorial. It's a factorial. Okay, so I want to show that I want to compare bn plus 1 with bn. And I want to know which one of these is larger. Well, let's cross multiply n factorial, n plus 1 factorial. Which one of those is bigger? N plus 1 factorial, because remember n plus 1 factorial, you can think of this as n plus 1 times n factorial. So this one's bigger. Like 3 factorial. We think of it as 3 times 2 factorial. Same idea here. So I've established that the b sub n's are decreasing. So now I need to take the limit and show that it's 0. Limits are hard when you have factorials, so you usually cannot compute them directly, so you use the squeeze theorem instead. 1 over n factorial. Well, that's always positive, so it's bigger than 0.
Less than
over n. Remember, with the squeeze theorem, you need the limits of the two end pieces to be the same. So I need a limit of 0 on the other side. Because n factorial is n times n minus 1 times n minus 2, right? So 1 over n factorial, this is going to have, I guess for 1 they could be equal, so I should put less than or equal to. So in general, the one with the factorial has the larger denominator, so it gives me the smaller number. Okay. So we're using the squeeze theorem. I'm going to take the limit of 0. What do I get when I take the limit of 0? 0. The limit of the other piece, 1 over n. 0. They're the same. All I care about is that they're the same. It has to be 0. So the limit now of b sub n is 0 by the squeeze theorem. Okay, so I've checked my two conditions for the alternating series test. It was decreasing and the limit is 0. So now I know that this series converges, so I want to find the sum correct to 3 decimal places. So I'm gonna have to take a partial sum. So let's take our series here, which was n equals 0 to infinity, -1 to the n over n, factorial, and start writing out some of the terms. Our S is the sum, so let's start by writing out some of the terms here. So 1 over 0 factorial, 1 over, well, it should be minus -1 to the first is -1, minus 1 over 1 factorial, plus 1 over 2 factorial, minus 1 over 3 factorial. Okay, let's keep going. Plus 1 over 4 factorial. Ooh, that was bad factorial. 4 factorial, minus 1 over 5 factorial. I need just a little bit more. I'm trying to fit it in. Plus 1 over 6 factorial, minus 1 over 7 factorial. And then this continues on, so I'm going to stop it right there.
We don't have to see that because, like,
we know that it converges,
yeah,
right? But we wanted to find an estimate for the sum, which is what we're trying to do, that's within our margin of error. They said I wanted it to be correct to 3 decimal places. So let's write out what these numbers are. 1 over 0 factorial, that's 1. 1 over 1 factorial is 1, plus 1/2, minus 1/6, plus 1 over 24, minus 1 over 120, plus 1 over 720, minus 1 over 50/40, and so forth. Okay? And I said that the error comes from where I cut off my series and I compute the partial sums. So I just need to calculate these numbers and see when is the first time that I get something smaller than 3 decimal places out. Okay? So 1 is too big, -1 is too big. And really, we're only worried about the number, not the negative or positive. So 1/2, that's 0.5. 1 over 6, it's 0.166 repeating. I need to have 3 decimal places of accuracy, so I need to have 000 as the beginning part of my decimal. So you would look at the next number, 1 over 24, 0.0083 repeating. I still don't have 3 decimal places here. So I keep going. My next number was 1 over 120. Oh, sorry. 1 over 24, that's the wrong number. That's what goes in the next spot. It's gonna be 0.416 repeating. Here's the 0.0083 repeating. And you gotta look until you get to 0.000 something. So 1 over 720, 0.00138 repeating. I still don't have 0.000. So when you do the final one, 1 over 50/40 that I listed, 198, that's rounded. Here, this is gonna guarantee that I have 3 decimal places of accuracy, because this is my error. So what I do is I go up here, and this is gonna be my error that I want. So what you're gonna do is you're gonna add up all of these other numbers that I've underlined in red to get your estimate for your sum. Okay, so if you add up all of those in red, your estimate is going to be 0.36, approximately 0.368. And that estimate for the sum is correct to 3 decimal places. So if you were able to actually find the sum, the first three numbers would be 368. Okay?
Is that because you stopped at like, you know how it's one over and it had like 3 places? Is that why you stopped?
Yep, that's why I stopped there, because I want to have, our estimation theorem says that our error comes from whichever term. When we cut off, it comes from our next term. So I cut it off at, I cut it off at that 1 over 720. So my error comes from this part I underlined in blue.
Yeah, it's 4 places, right?
Uh-huh, and that's 4 places, yeah. Where my arrow? Yeah, I can scroll down. Yep. All right, so you have a new daily quiz. Normally you have 2 days to complete it, but I'll give you until Sunday, and there's a new section of homework on this alternating series test.
I had a question. What do you mean you cut off, like right there?
So what you're doing is,
I mean, I know
I
you
can't,
stopped right here.
yeah, I can't add up all of these numbers, right? Because there's an infinite number of numbers here. And so I can't actually explicitly find the sum. I'm gonna just add up a finite number of them, and that gives me my partial sum, which I'm using to estimate S. But they said they wanted me to find an estimate where I was correct up to 3 decimal places. And so the way alternating series work is that this theorem up here, let me make sure I do this one. This theorem up here tells me that my error comes from the next term that I didn't add. Okay? So I look here, and that's what I'm trying to figure out here, is which term is going to give me an error that's within what I want. So I write out all these numbers here without the negative signs. I write them out, and this is the first time that I'm correct for 3 decimal places. And so this is where I need to cut off my list of adding. So I'm only going to add the red, not the blue, and if you add up the red, you're going to get this decimal. If you round it to 3 decimal places. And then this is going to be, if you were able to find S, the first 3 digits would be 368.
Oh, okay, that makes sense.
Yeah.
Thank you.
You're welcome.